So one of the things that we always need to consider when choosing our object detection neural network is the accuracy versus time. So accuracy represents how precise the neural network is when making predictions, and time is the time that the neural network takes when it's making inference or when it's making prediction. So this is a graph from the paper that I have referenced before, where they have made so many experiments with 3 different types of neural networks, which are faster RCNN, RFCN, and SSD. And for us, we'll only consider faster RCNN and SSD in this course because SSD is very fast and faster RCNN is very accurate. RFCN is somewhere in the middle, so we will not be considering it in this course. So as we can see in this graph here, so this shape here, circle, represents faster RCNN based neural networks. This shape here, which is a square that is a little bit rounded, represents SSD neural networks. And the colors, they represent the different backbones that are used in this with these neural networks. And what we can see is that on the x-axis, let me just make this smaller. So on the x-axis here, we have the GPU time. So this is the inference time when we pass the image through the neural network. This is how much time it takes to make the prediction. And this is in milliseconds. So at most here, it takes 1 second, 1000 milliseconds. And here we are around 100 milliseconds, for example. And what we can notice immediately is that faster RCNN-based neural networks, they tend to be the most accurate. As you can see, all of these circles, they represent faster RCNN-based neural networks. And they are the most accurate ones between the rest of the neural networks. And if we look here at the bottom where we have smaller accuracy or mean average precision, this MAP is mean average precision, which represents how precise the neural network when making predictions. So here at the bottom left, we can see mostly RFCN and also SSD based neural networks. And here what these represent are the neural networks that are the fastest, but of course we have to compromise on accuracy here. So whenever you make a decision about using SSD or faster RCNN, you can come back to this graph here and you can make so much conclusions just by looking at it. For example, we can see that with inception v2 and using SSD, we get somewhat a possible good precision here, and also we're not compromising too much when it comes to the time of predictions. And also, of course, there is another thing here that is not shown explicitly in this graph, which is the resolution of the images. So when we see these 2 points here, or these 2 shapes here, they both represent SSD with inception v2, but we see that they represent 2 different things. And basically the change here is based on the image resolution. So in this paper, they had low resolution images and high resolution images. So for example, we see here, this one here compared to this one, this is faster because the image resolution that we are using here is lower. I believe it's 300 by 300 or something close. And that's why we see, for example, this arrow pointing to this one here. It says SSD with inception v2, low resolution. And the same thing here with MobileNet, low resolution and used with SSD. So just using this graph, you can get a much better idea about the choices for your backbone, for example, and for for your specific neural network, vector RCNN, SSD, or whatever. So this is just one of the graphs that is shown in that referenced paper, and we will look at other graphs in that paper as well so that we can make better decisions.